I'm going to very quickly run through question 2 on the additional questions on the impedance handout. So the question basically gave you the information that after a test on a circuit, on a 24 volt DC test produced a current of 8 amps, a 24 volt AC test produced a current of 6 amps. So from that we can find a range of information. Part A of the question asked you to find the resistance of the coil of wire, and here is our resistance information. 24 volts DC, the current flowing will give us only resistance, so quite simply R equals V over I. Put the numbers in. 24 volts, 8 amps, the resistance is going to be 3 ohms. I'll move over here. Part B asks you to find the impedance of the circuit, and that information is here. If we connect a coil onto an AC supply and it takes a particular current, then impedance is what produces that current or controls that current. So Z equals V over I, just a variation of Ohm's law. Put the numbers in. 24 over 6, and that's 4 ohms. This is important. You will always expect impedance to be higher than resistance for the circuits that we're doing. So, part C asks you to explain. As soon as they say explain, you're going to be using words. You're going to have to write. So I'm trying to do this very quickly, and I'll quickly just speak off the top of my head of what would be probably a suitable answer. So it would be something like, using a DC supply, the only opposition to current flow is resistance. However, using an AC supply, the opposition to current flow is impedance. That's what we said there and did there. The current is lower on AC because impedance is made up of both resistance and reactance, not resistance alone. In a DC circuit, it's resistance alone. In an AC circuit, it's resistance and reactance. So the combination means the opposition to current flow is higher. Okay, that'll do for that. The final bit, part D, asks you to find the reactance of this coil of wire. So we've got R and Z. X is what we're looking for, and you need to think about triangles. So reactance. Sketch, not accurate at all. The resistance is here. That's 3 ohms. The reactance is going to be up the side, and the impedance is here, and that is 4 ohms. So this is what we want. This is Pythagoras. So get rid of those. XL, this bit, is the square root of big one, Z squared minus R squared. Put the numbers in. Square root of 4 squared minus 3 squared. Put your answer in. That is 2.65 ohms. So at that point, if you're asked to find the reactance, that's the simple way of doing it. Think triangles. I'm just going to add something in that isn't actually in the question, and it's to do with XL. Suppose the question asked you to find the value of the inductor. There is only one formula that we use in electrical work that has L in it. That's capital L for inductance, and that is XL, not very well done, is 2 pi FL. That's the only formula we use with an L in it. So if you want to find L, let me flip the paper over. I hope this is usable. So XL is 2 pi FL. Transpose it to make L the subject. L equals XL over 2 pi F. If we then put the numbers in, XL from the previous page was 2.65 divided by 2 pi times, I'm going to assume it was 50 hertz, I don't think we mentioned anything. And if you calculate that lot, the answer comes to 8.4 times 10 to the minus 3. So don't forget this bit, you can't ignore it, that is milli. 8.4 millihenries. So lots of that is very useful in your untimed written assessment, and it will get you through some of the questions that are at the end of the impedance sheet. Good luck.